In today's video, we're going to look at how atoms can form covalent bonds by sharing electrons. And we'll also see all the different ways that we can draw these covalent bonds. To very quickly recap, we've already seen how some atoms can form ionic bonds by transferring electrons from one atom to the other. This makes oppositely charged ions that are then attracted to each other through electrostatic forces, which hold them together. And the reason that they transfer these electrons is so they both get a full outer shell. Now, this works great when one of the atoms has too many electrons and the other one has too few, like with sodium and chlorine. But what about when we have two non-metal elements, like two chlorine atoms? Well, in this case, both of them need an extra electron to get a full outer shell, so giving electrons to each other isn't going to help. Instead, what they can do is share some electrons, and as each atom needs one extra electron, they each share one of their own, so that together two are being shared, and they each get one extra. The way that we've drawn this is called a dot and cross diagram, and when you do these, you need to make sure that you draw one of the atoms with dots and the other with crosses, so that we can tell which electrons belong to each. Also, even though we've only drawn the outermost shell of each atom here, you might sometimes have to draw all of the shells. Just make sure you check the question to see what they want. An easier way to draw covalent molecules, though, is with a displayed formula, where we just write the chemical symbols of the atoms and use lines to join the atoms that are covalently bonded together. The great thing about these is that it's easy to draw big molecules that would take too long or be too complicated to draw as dot and cross diagrams. For example, this here is a molecule of sugar called glucose, which you don't need to know about specifically, but you do need to be able to recognize that this is a displayed formula. The downside of displayed formulas, though, is that they don't show you anything about the 3D shape of the molecule. For this, we can use a 3D model, which tries to show how the atoms are actually arranged in real life. For a slightly harder example, let's try to draw the covalent bonding in ammonia, which we just saw. It has the molecular formula NH3, so we can tell that there's one nitrogen and three hydrogen atoms, and the first step is to draw all of these out. In our example, we'll only draw the outermost shells. The next step is to think about how these atoms can fit together so that all of them have full outer shells. Remember that because this is hydrogen's first energy level, it can only hold a maximum of 2 electrons, so each hydrogen is going to need one extra electron to fill their shell. Whereas because this is nitrogen's second energy level, it can hold a maximum of 8 electrons, so it's looking for an extra 3 electrons to become full. So if each hydrogen shared 1 electron with the nitrogen, then all of the atoms would have full outer shells. And that would be our dot and cross diagram all done. Or if we wanted the displayed formula instead, we would just rub out all of the shells and electrons, and instead place lines wherever electrons were being shared, which just means placing a line wherever there was a covalent bond. Now, when it comes to the 3D model, things get a bit trickier, because it's hard to predict what shape the molecule will make. Luckily though, you don't have to know this just yet. You just need to be able to recognize them. The last thing we need to cover is the types of substances that covalent bonds can make. The examples we've seen so far, like chlorine and ammonia, are called simple molecular substances, which are small molecules in which the atoms in the molecule are joined by strong covalent bonds. But between the individual molecules, there are only weak intermolecular forces, which are easily broken. Other simple molecular substances worth knowing are water, which is H2O, and methane, which is CH4. Covalent bonds can also be used to make much larger structures though, such as polymers and giant covalent structures. We cover both of these in other videos, but basically polymers are long chains made up of lots of repeating units, which we call monomers, and are used to make things like plastic bags and t-shirts. Meanwhile, giant covalent structures are things like silicon dioxide, diamond, and graphite, which can involve billions or trillions of atoms, arranged in a regular lattice. And because all of the atoms are joined by covalent bonds, they're really strong.